So this slide tells you a bit about ActiveMQ, what it is and what our protocols and what our support it does. So basically, we are not bothered about this much support like XA, JCA, Java EE. We are just using the JMS part out of Apache ActiveMQ. Okay. And then going forward, it tells you a bit of history. So it's not Apache started. So it was started at CodeHost at like 2005 and then moved to Apache at 2006. It's pretty much recent. We explored a lot of their products, but this was something which we picked finally. Okay, then there are like some screens which talks about JMS if you are not aware. So JMS is just an API, but API to access enterprise messaging systems. So JMS, like here I say that JMS is pretty much similar to JDBC because JDBC is an API to access relational databases. JMS is an API to access messaging servers or messaging system. Examples: ActiveMQ, JBoss messaging, WebSphere MQ, Oracle Web Logic, or IBM MQ series. Okay, so at very high level, and actually that's most of it. So JMS has two models to work with. So JMS old API is 1 dot something and latest there's 2.0, but the model hasn't changed. It's like point to point and publish subscribe. So point to point means you have one producer and you have one receiver will get the message. Publish subscribe is more like a mailing list you give or something, and everyone listening on that mailing list will get the message. So this diagram. So basically in these slides you will see most of the things as diagram. So I'll keep on explaining. So like in this is there is a sender which sends a message, and there might be different. There might be many number of receivers listening on different. So those receivers are actually running on different machines. Okay. So they may hook into a messaging server where this queue is, and they may start listening. But this queue, the concept of the queue is that only one receiver out of it will get the message. So if this message, if this receiver goes down, then it will go to the second one. Or say that this receiver is like loaded. So there's too much load, so it cannot take up the new message. Then it will go to the second one. And how does the receiver pulse a message? So there are two ways. Receiver can attach a listener. So a queue will deliver the message to the listener whenever it comes, or receiver can proactively go and get the message out of the queue. So there are two ways it can get the message out from the queue. Okay, and similarly like topic. So in this only one receiver will get the message, not all. So if it's delivered to this, those queues will not get. If it delivers to the middle one, the other two will not get the message. But topic is different. So topic is when a publisher will publish a message. We call it publisher. It could be like producer, or call it anything which is dropping a message. So when this guy publisher is dropping a message, it knows that is going to drop into a topic because the code API is like that. You create a topic and then you create a session. Basically you create a session, then you create a connection, then a session, then a topic, then a publisher on that topic so that you can drop a message into it, and then you create a message. So in this case, all the subscribers who are subscribed to the topic will get the message. So like in previous case, I said that to pull the message, there are two ways. In case of topic, there is those two things. There's like durable. So durable means this topic is inside a messaging server. Durable means whenever a subscriber is attached to a topic or a messaging server for a topic, the subscriber will give its ID to the messaging server, and messaging server will store that. So say that at one point of time when this message came, this subscriber was attached to the messaging server, but right now it's not running. So messaging server will keep that message inside the topic till the time the subscriber comes back again. But there were no subscriber, there's something new coming up, there's new subscriber, then no, that durable thing doesn't work. But it's called durable subscription, wherein if a subscriber had attached to it, but it's not running at that point of time, message will be there. Once it comes online, it will get the message. But the main idea of topic is that one message will be delivered to all the subscribers. So those were the two JMS models which I started with. So basically, we have used both the models, queue for like request reply and topics for events from the remote ending server. Okay, so basically this slide tells you an overview of how request reply works over JMS. So in this case, there is this client which is working both as a producer and as a consumer. So there is a queue on which you drop the message. Message will be delivered to the consumer. Consumer will consume and produce a new message for you that will be delivered on 10 queue. And how does this client know that this is a response to the message we have delivered? So there is a JMS correlation ID which is used. So there is one ID which will be injected into the message, and it will use that to understand, okay, this is the response to the request it sends. There. Okay. And there's this concept which, so previously we were non-persistent messaging, we were trying to use this, but there were needs when persistent messaging was suggested. So we use KahaDB to actually, KahaDB is like default for this ActiveMQ. So we have moved on to this persistent messaging. So this part, I don't know why I brought it, but non-persistent messages are faster, and we actually don't need it. So might have some reasoning, and he enabled it. I don't know. Okay, so persistent messaging, it will impact the performance, like too much of like performance impact. The reason is then when a client is so publisher or the producer for topic or for a queue, when a message is created and is being delivered to the broker, then at that time broker will not send you the response or the receipt or the acknowledgement back unless it has stored the message inside the message store, inside the database. So and that takes time. So that's why it's not very performant. But non-persistent messaging is till the broker is up, everything will be perfect. If broker goes down, it will lose all the messages. So that's one thing. So if broker crashes, you lost all the messages. But in OEM case, it was okay because broker is attached to a remote admin server or on the OEM side also. So if one thing goes down, we are just okay because once it comes back, we poll for the status and poll for everything again. So we were not needing the persistent messaging per se theoretically. Okay, then so I covered JMS basics, and now it's ActiveMQ basics. Okay, so ActiveMQ have two major concepts. So ActiveMQ is a broker, it's a JMS broker, but to connect to the broker, there's this thing called transport connector. Transport connector is used by the client. So client will be consumer, producer, subscriber, publisher. Okay, and there's another kind of connector called network connector. Network connector is when you connect two ActiveMQ brokers. Okay. Okay, and this is a bit of code snippets because this is the basic thing. This is something we have used, and this is most basic stuff. So transport connectors. Transport connector from this slide, is something a client will use to connect to the broker. So transport connector, how you enable and how you set it up. So here in this case, you create a broker service. So this is actually your broker. You say that add a connector. So this basically should say add transport connector, but this is how the API is. So you say add a connector. So that means you're saying that broker will listen for producer, consumer, publisher, subscriber on two ports now, 61616, 61618. Okay. But there's a difference because initially in the slide we mentioned that it supports multi-protocol. So probably this client is, it understands how to send messages over NIO protocol. But this client, which is consumer in this case, it doesn't understand NIO but can send over TCP. So that's why there are two ports. But broker is single. It's just listening on two ports so that it can support multi-protocol for the clients. Okay. But still the queues, the topics will be just one which is created inside it. So this is the basic code when you start a broker. So you instantiate a broker, you tell on what ports and what scheme, what kind of protocol will be used by the clients to connect on this particular ports. Okay. And then you start a broker, you wait till it is started because you cannot proceed unless it is started. So there's the API call. So the thread which is starting the broker will go and wait there till it gets. And the same thing you can work out with an XML, config XML. So there's like broker. There's a lot of broker properties which you normally set. You may set as an attribute or you may set as an element here. That's not config. It's for this. Like these two transport connector will work out like this. Okay. Okay, so this is something you can read later. It is not needed for now. These are again code snippets. When I show that, okay, it's the same thing. Is you are creating a broker service. Now you can name a particular broker. You can like this is how the API is called. You can set whether you want persistent messaging or not. You can set if you want GMX. So GMX could be a security hole sometimes. So normally you won't enable or you can enable. Like in our case, we have a system property. If you set it, it will be enabled for whole open edge management. So that property is inserted here inside our code. So if you enable that property, it will be enabled here. Okay, and advisory support we definitely need because that's how the remote connections will work. And management context is if you want GMX support to be there, but you want like anyone on a remote machine to connect to that GMX server, then you define this. And here in the previous picture, I simply was adding like what protocol I need and what port I need the transport server to the transport port to be up. There's a way which we use for reasons which you know when you see the code. So this is how we are creating a transport connector. So we actually create because this is a server listening on a port. So we say that, okay, transport factory, and then we create the transport server. Then we create the transport connector out of that transport server. And then we attach that transport connector to the broker. So this is how we did inside the open edge management, and there are reasons why we did, because there's advanced setting which we have to do when we are attaching. So those were not possible if you simply give a URL here. Okay, so and then you start a broker, then you wait till it starts. Now this is again one small code snippet on how to enable the security. So the ActiveMQ has another concept of plugins. So basically anything other than connectors will be called as plugin. Like in this case, there's a plugin for security, wherein you are creating local users and local users basically and their roles. And like you set the name and then you set the plugin. So you instantiate that plugin and you set it. So it takes an array, you can have more plugins, and it runs on single port TCP and 61616 and broker standard. Okay. Similarly, here there's another thing pretty much important we use it. Okay. There's something called VM protocol. So if you understand what happens is, if there's a broker running on a different machine and clients are connecting, like producer is connecting, and then there's like on this diagram. Okay, so there's producer on one machine and there's consumer on another, and broker is running on another machine. Then it's fine, but sometimes, and this thing they have used in open edge management, it will improve the performance if you say that, okay, we are running a broker and on the same machine, on the same JVM, I'm running a consumer. Okay, so in this case, you will use VM protocol and you just specify the broker name, the one which you said while starting a broker. So that way it will start communicating over VM protocol, which gives you a lot better performance. And the other guy, maybe a producer or consumer, can connect on TCP port and can start. So that's one thing. This is for the case when you're running a broker in the embedded mode. Okay, this is camera, this I'll take a page. Okay, so This is another way of creating a transport connector. So, okay. Now this is the different. This is creating a client connections. So yeah, so this code is important. So basically what we do is, so once the broker is running on some machine, you take that URL, you create a connection out of it. Basically you create a connection and then you start the connection. So this client is connected to that server, connection is started, and then the first thing you want to create is a session, because session is where you will start creating topics and everything on the broker. Okay. So transport connector, what are the protocol it supports? So these are the ones. We initially started with TCP, then we realized it's all our code, admin server and organized management. So we moved on to NIO. Okay. And these are, so don't confuse like this transport, so this XML element transport connector. So these are like, you can pick any name. The actual protocol will be picked from the scheme, the scheme pulled from the URL. Okay. Okay, this is one concept which I initiated and this is running inside OpenEdge management. So what happens is that if you run a broker on a single machine and like run a broker, so previously we were thinking like something, this is OEM and this is broker, ActiveMQ broker. We didn't know that where we would run this, and this is remote admin server. So we were thinking about this configuration. So this will connect to broker, and this admin server will connect to broker. So maybe if they have a queue, so this will deliver a message onto the queue, and this will connect to here. It will have a consumer, and this will have a producer. Okay. Once it drops the message, it will listen. That message will go here. It will create another message that reply back, reply queue, and that will be delivered here. We are thinking about this, but we realize it's not good because we didn't have one place where we can start the broker. So what we did is, we broke apart the broker. Okay, so maybe this is running on 6.1.6.1.6.1.9. So what will happen is that OEM will start talking to the local broker over VM protocol, which will be good. And this admin server will also start talking to broker over VM protocol, which will be good. But overall, what ActiveMQ has this feature is, it will say that don't think about broker as divided pieces. Think about one messaging server running. Okay. So what will happen is, what we have inside OpenEdge management, the overall. So whenever this broker is started on this remote, like admin server, say the machine name is machine 1. Okay. So what will happen? There will be queues created. So whenever this broker will come up, there will be queues created. The queue name will be machine 1. Sorry, the queue name will be Pratham 1, machine 1, then plugin name. Let's take example of database DB, and just the plugin name. Okay. So this was initial configuration, it got changed, but we'll have something like this: Pratham 1, machine 1, app server, Pratham 1, machine 1, web speed or WSA. Okay. So what will happen is that there are consumers. So there are consumer listening on this. There are consumer listening on this. There are consumer listening on these queues. Okay. So basically, these consumers are nothing but the old code, the wrapping of the old code, which will reply you. So if you drop a message here, It will be delivered to consumer. Consumer will reply you back on some thank you, which you actually create and tell. So what this network of brokers says that, it says that you will still consider them as one piece, one broker, which will have these queues. So what happens is, inside this broker, whenever there is a network connector created here, they will know because of another feature of ActiveMQ, which is advisory messaging. Okay, so this broker now knows that okay, we have connectivity with this broker using advisory messaging, and it will go on and create inside this broker. It will go on and create pattern 1, machine 1, DB. Okay. So this queue is in this broker, this queue is in this broker, but because these two brokers are connected, and what happens is, in this admin server we have a producer. Okay. So what will happen is, OEM says that okay, we want to connect to particular database, go and drop a message here. But in this broker there is no consumer for this queue. It's actually consumer is here. So what will happen with advisory messaging, these brokers will get connected, and this message which was being delivered here will actually get shipped here automatically. You don't have to do anything. This message will go here, and that's how it will be consumed, and it will revert back on a temp queue which is here. But this temp queue, there will be a replicated here. It will come the response, and the response will come back to the client. There will be a consumer here on which the response will come back. So this is the overall architecture on which we have created the code. Okay, so this network connector is kind of important because this is what we have used to make the connectivity. So like this diagram shows that producer is connected on this port to the local broker. So basically this diagram should have said that work on VM protocol. That's kind of okay. So it's just saying that there is an embedded broker which is, or there might be a possibility that this broker is running close to a machine which is where the producer is, and this broker is running close to a machine where the consumer is, nearby to consumer. Okay, so like TCP or VM protocol, it connects to the local broker. This one connects to the local broker. They will create a queue of the same name, and based on where the producer is and where the consumer is, message will be taken over by itself using ActiveMQ advisory messaging. Okay, it actually helps you in performance. These are the things which are realized based on something I did a research and some tests. So basically what happens, you avoid lot of network connection if you have a remote broker running. So basically there will be only one network connection on which all the messages will be delivered. Had you been creating one messaging server, you would have been creating all the connections from all OpenEdge instances and all remote instances. So that kind of avoided. So network connector is kind of important. How it translates into API. Okay, network connector have two types. One is forwarding bridge and one is duplex. This diagram explains what it is. So this says that okay, in this case, this connection is duplex and this one is forwarding bridge. I mean one side. So what happens is, in this case you have producer here and consumer here. So its forwarding bridge will work for you, and that performance the performance will be better for this kind of a network connector. Wherein it says that a message which is produced here will be shipped here, but a message which is produced here, I mean there's a queue name, same queue name. If you drop a message here, it will not come here because there is one-way communication here. If you want that kind of a piece wherein like we needed that kind of a piece and we are using duplex. So what it says that if there's a queue here, you drop a message producer and you can consume it here. And likewise, if you have a queue, you drop a message and you can consume it here. If you need two-way communication, then you need to have duplex. How it maps to the API call is okay. I'll talk about the API call, but these are another way in which you create a broker using XML config. So we use it just in case you want to change the implementation what is running inside OpenEdge management. So it will also see for XML if that is there. basically start. Okay, this is something else. Okay, so this is how you create a network connector. So you saw API call which was add connector. This is add network connector. So that means a broker is connecting to another broker. How this translates for XML, inside XML you'll do something like this. Network connector name and the URLs. So in this case, actually one instance is connecting to two brokers. So one broker is connecting to two brokers. So that's how you separate them by comma, and then you do. And this is how you set if you want duplex. Forwarding bridge I think is default, so you'll have to set duplex to true if you want it. Okay, and this is client failover. We haven't used this thing, so there's something you can read by yourself if you want to understand. Broker architecture, this is something you may want to look. That's pretty much it. Basically, it like talks about other things, but you don't want to know to work on organized management because these things we evaluated and we thought we don't need it for now. And this is how you enable JMX. JMX is enabled in our case, and there's this thing. So JMX will be enabled, and you can connect JConsole or any other profiler to connect to that. But this is how you can change the default. So you can enable JSON by this property. But if you want to change the port, change the domain name, then you will have to provide this management context element so that you can configure these properties. And you have to configure, you will have to configure these properties if you want a remote connection to be enabled. So JMX, like JConsole locally will work, but unless you have this, it cannot work from remote. So if you want to connect from remote, you create a URL, something like this. So this URL will come help when you are diagnosing something. Okay, this is okay, this is kind of okay. Okay, this talks about monitoring ActiveMQ with advisory messaging. So this I'll take up later because there's way too much information which I can just show by code rather than this. As I said that in this case, the OEM broker already know that there is a connection to a remote admin server using advisory messaging. So it knows that it can create a queue named for that machine one where the admin server is running. So that is based on advisory messaging. Okay, that's pretty much it. Now, okay, so basically in this ActiveMQ broker example, what I'm trying to show with this example is just the APIs, okay, to get you familiarized with the APIs. So these are the different ways in which you can start a broker. So create an instance of the broker service, and this will also give you the required jar files. Okay, so you can download the latest, or you can check if so you can actually use which is used inside the project. So I'm just trying to familiarize you here. So these are all running ports. If you want to start a broker on this port, these are all running ports, and this is how you actually go on and secure. So basically same piece of code, but I used a broker plugin. So these are all my tests which I had to run so that I can put the code inside of now. And this is how you actually create the connection factory. So this is like client connecting to a particular broker, okay? And this is how you use VM protocol. This is how you can use configuration. So either you can set configuration here so that it becomes easier in the URL, but normally you do with API call. So as I said that to connect to a broker, you'll need a connection. So you create a connection, then you start a connection, then you create a session, and then like in this case, you create a queue. So basically this API says that create a queue, but it's not always creating a queue. If the queue already exists inside the broker, okay, it's kind of ignored. It just says that you want to work with the queue. So you get that object. So it says create queue, but maybe it's creating just the object for you, or if required, to create the queue if it's not existing. So you got the queue. Now on the queue, you want to consume the messages. So you say session create consumer on this queue. So now you have a consumer, and so I said that to the consuming on the queue, it can either attach a listener. So this is how you attach a listener, and there's one API call in which you can fetch the message. So in this case, I'm attaching a listener. So whenever there's a message on the queue, it will be delivered to that listener. So ActiveMQ will take care of that. You don't have to worry about how to get the message. Okay. Likewise, there's another API called using a string. This is not required. We didn't use this feature. And there's one tool which I want to familiarize you is this project. So you can use this with any project, like in use this with any broker. So, but in this particular case, just for the demo, I've created this broker. So this broker is pretty simple. Like normally you create a broker service with instantiating the broker, but this is another way here I show you is that how if you want to instantiate the broker using a config file, like broker config file. So in this case, you just provide the config file and say broker start, wait until you start it, and this is pretty much it. So basically all the information which we saw will go here. Okay, so in this case, broker management context for JMX kind of stuff. I enable JMX and provide this the configurable things like port, and so that I don't worry about default port being taken. And this is a transport connector, so it like work on TCP and listening on 616.10. Okay, so that API calls are mapped into this XML config, XML, and I use it here to actually create the broker. Okay, the tool which I'm trying to use it is kind of amazing. I got it from somewhere. So it says that consumer tool. So what happens is you just will have to give a URL to a, like in this case, we are giving a URL to a running ActiveMQ broker, and you can configure that this is a consumer. So how many consumer do you want to be running? So like in case of queue, those will be receivers. In case of topic, it will be like subscriber. And you can say that, okay, this is a consumer, but consuming from what? Is consuming from topic or is consuming from a queue? Okay, and you want verbose, so you don't have to worry what goes inside it, because you can see the code is good for learning, but basically what you are interested in, you are testing a particular ActiveMQ broker configuration and how it will perform, how will it work, does it work or not, does the security works or not, does the username and password works or not. So you use that, and this tool uses a class called command line support. So basically this verbose, if you are setting verbose as here, so it will be mapped here. So any property which you see here can be set at command line with this. So if you are saying topic, that means it will be a Boolean property here, topic. So if you want to consume from queue, just say queue and that's it. Okay, if we understand. And likewise, you can provide username, password, URL. Right now it's picking up default, but you can change at command line. Similarly, on the other side, the producer side, there's this tool. So you can say that, okay, you want to produce messages for a topic, you want to produce a message for a queue, and you can say that, okay, how many messages. By default there are 10 messages that you produce. Okay, and you can actually tell the topic name, or it will pick that default as tool default. Okay, so this tool will actually produce a message for a topic or a queue at random, so you can perform your testing with this producer and consumer tool. Just to run this and show you how everything works. So let me show you the run configuration. So this is tool ActiveMQ broker, and there are no argument here. There is argument for Java 1.5 JMX, and this you don't have to worry. This is just needed. And these are the program arguments, none. So you are starting a broker. You saw the code already for starting a broker. It's basically picking a broker configuration from a file, starting the broker. That's pretty much it. So there is nothing with that code. It's just starting a simple broker running on 61610. So let's run this. Okay, so broker got started, and it will give you port somewhere on this port 61610. And it also started JMX. So this is the URL which you want to look for if you want to connect from remote machine. But if you are connecting local, it's no problem. Like, give me an example. Okay, I started JConsole, and it will automatically show me because it's running locally on the same machine, so it can ask the JVMs which are running. So this is it. So this is basically we are hooked for GMX, JConsole for ActiveMQ broker. And majorly you are not bothered about memory usage or threads. We were, but it's not normal. Normally you want to see, okay, what goes inside the broker. So if you see here from the config file, I said that I want running JMX port to be this, and this is the domain name. So this domain name got mapped here. So this JMS tool, which you are seeing here, JMS tool is JMS tool. So this is all the MDs which are exposed from by default by ActiveMQ. This will come as real help. So this basically shows about broker. There are lots and lots of attributes which you can read about the broker, MQs and everything. So it will give you all the information, and it says that there's one connector running. So this will give you. So it's running on OpenWire protocol, and you can see the like properties that SSL is enabled or not, and there are other operations which you can do. Okay, so this, keep a watch on this. This will change. So right now you have a broker, and broker is listening on one connector. Okay. Now what will I do? I'll run this producer. Let me run the consumer before, because consumer have to be attached. So yeah, consumer, you want to see the run configuration. So consumer, as I said, that those properties which are on the class will be set from the command line. So on this command line, I'm saying that I want to consume on a topic. I want 3 receivers, 3 subscribers. So I just say parallel thread 3. And this is where, so 61610 is where the ActiveMQ is running. So I just pass this URL, and I say that I want to test topic. So consume from a topic. I'm not giving topic name because it will pick default, and that works for this test case. And I want verbose output. Let's remove that. We give a lot of things which I'm not aware right now. Okay, so I attach consumer. Okay, so it says that there are 3 parallel threads running, and they will start consuming. Now there will be a change in here. So previously it was broker and connector. Now there are connections, because connections have been created to this broker from there, and it says that there are subscriptions there. There is a topic created. So these topics are created by default by ActiveMQ. You don't have to worry about this. But this is a topic which is being used for this. This is the topic being used for testing tool default. Right. In this case, it says that this is the topic, but there's no DQ, no MQ, no message, nothing. Right now there is no message. Okay, but it says that there are 3 consumer, which I showed you that. Okay, there were like 3 threads. Okay, so there are 3 consumer. Now let's start producing messages on this. So you want to see the run configuration. So producer run configuration, there are arguments. So I want to produce messages on topic, default topic name. It will pick, you just say topic, it will pick a default name for that. So that default name will be common between consumer and producer. So you just say I want to produce some messages on a topic, and this is where the broker is running. And basically by default it will drop 10 test messages. Okay. So now run this. Okay. So this is what the producer did. It started sending 10 messages from 0 to 9. Okay. And it dumped some of the information from the broker, which you don't want to know for now. But let's see what happened on the consumer side, consumer tools. Okay. So consumer, there were three receivers which were receiving messages, and this is topic. So if you see this thread 234, basically thread, it just picks a random name. So there were 3 receivers, and this is the topic. So all of them got the message. This message was replicated thrice and was delivered to all 3 receivers. Similarly for message 1, so these 2 got here, thread 4, so these are basically subscribers, thread 4, thread 2, and similarly for, this is for the another subscriber. Okay, so you see that 10 messages were sent, but now 30 got received. So this is consuming from default topic. Okay, now things will change here in JMX. Okay, I just have to refresh. Okay, so it says that consumer 3, those consumers are still attached. So it says that consumer has 3. Okay, and DQ is take the message out. So 30 messages were delivered. Okay, but 10 messages were actually dropped inside the topic, but it replicated the messages into 30. Okay. So this is something which you get if you have JMX. You can see what's going inside. Okay. It also shows you the producer. Producer actually ended, so there's not much information. But subscriber, if you put in some information that okay, there were subscriber to this, and you can see that there are 3 subscribers. Okay. So if you want to test conceptually how the queue will work from that diagram which I showed you, so this tool will come kind of help. Like, what if I change the circumstances here? That in this case, I said 10 messages becomes 30. What if we want to test a queue concept? Okay. So we will start the broker, the same thing again, because broker is common. It doesn't matter what you use. So I start the broker. Okay. Now I go to the run configuration for say consumer. Okay, and I change it to actually queue is default. I don't have to give, and I say that 3. So this is actually 3 receivers which will be created, and this is the broker wherein it will get this queue. So run it. Okay, and then have producer produce the messages. As I said, you just remove and a topic will be created. Okay, so it's going to create a queue. The name is common between producer and consumer. So producer will produce 10 messages on the queue, and there are 3 receivers, but only 1 receiver will get a message. So 1 message to 1 receiver. So another message may go to another receiver, that is okay, but 1 message to 1 receiver. Okay, so just apply and run. So the job of publisher is done. It is saying that it delivered 10 messages. It's saying that it delivered to a queue. The name of the queue is tool default. You can see this.
So the receiving also would be random, right?
Yeah, but basically that thing is configurable, the receiving thing. But let's see what happened on the console. Okay. So in this case, it says that I'm consuming from a queue. The name was common.
Yeah.
Okay, and it's saying that okay. So the thread names are not very correct, basically, but okay. There are 3 threads, basically 3 receivers. So this one got a second message because you have so many receivers. So it did that. Okay. So basically, for 1 receiver, you will get messages in order. So like in this case, this receiver. So you got message 1, then it will not get message 0 because 0 may or may not be consumed, but it will get in order. So this is how it works. So basically 3 got this one. You got the point that I'm trying to say? So it didn't replicate the message.
Yes.
It was one message to one receiver. It could be any receiver at the time. Unlike you were saying, random. So maybe you don't want that. Maybe you just have one consumer. So I still have, let's end the broker and then let's restart. Okay, so I run the broker again. And this time I'll change the configuration for consumer. To the consumer, I'll say have only one consumer. Then it will really work as a queue. So queue of one receiver on that particular broker, and then I go and start producer. So producer is default; it will just produce 10 messages. And this is how. So producer has done the job. It has produced 10 messages on this queue. Okay. Let's see what happened on consumer side. So on consumer side, now you have just one receiver, thread 2, and it received all the messages in order. Okay. So likewise, you can use this tool if you want to check if you want to check how your configuration works. Okay. And all this information will kind of reflect on JMX JConsole, so you can see that. That's pretty much it. So for today, I'll share these two samples for now. You can go through and run this tool. This tool will actually get you familiarized with JMX as well. And then try to configure from there. That's pretty much it for today. Tomorrow we'll see what's inside, what is going inside Coconut management. Anything you want to ask?
No.